What's up, guys? Another video on equilibria. This time we're looking at this balancing act between rate and equilibria that we have to use in industry. Now, generally speaking, we're talking about the Haber process in this, which is this reaction, right? Our nitrogen plus hydrogen makes ammonia. Now, essentially, what we need to think about is this balancing act between yields, between rates, and between cost, because there's no point in having 100% yields if it takes us a very, very long time to get that product at a very, very high cost. And our graph sort of exemplifies this, right? So we've got lower temperatures give us a higher percentage yield. Therefore, that's sort of talking about our reaction being furthest to the right. A higher temperature, we've got a lower yield, our reaction shifted to the left. And pressure, the higher our pressure, the higher our yield. We've got this general pattern across there. But it's not as simple as that. So let's look at this in sections. So pressure. We use 200 atm. So that's because we know higher pressure gives us a higher yield, as we have more moles of gas on the right hand side. Yeah, so we've got 2 moles of gas on the right, 1, 2, 3, 4 on the left. We also know higher pressure gives us a higher rates, and then more collisions, more collisions. But high pressure, expensive. Therefore, 200 atm is a compromise. Because if we don't take cost into consideration, we could use 1,000,000 atm, right? But it doesn't quite work like that. It costs a lot to maintain that pressure, and it costs a lot to build machinery that can withstand that kind of pressure. So that is a pressure. Next, temperature. Now the temperature we use is about 450 degrees centigrade. Now we know a high temperature gives us a lower yield, right? And that's because we've got an exothermic reaction. Check out the next video for more information on that. The previous video, sorry. Also, high temp, high rates. Remember, we've got more collisions with greater force. It's also expensive. And again, 450 is a compromise. Mainly between rates and yields. So again, just to explain that a little bit more, again, in theory, if we use this 350 degrees centigrade, we're going to get an even higher yields, right? Our yields here compared to here, but it's going to be much slower. And so we're balancing these two ideas of speed of reaction and our overall yields. And our last thing, which isn't really covered by the graph, we obviously do use a catalyst as well. And we use an ion catalyst as faster rates, as we have lower activation energy, low cost. So again, we've got these three factors that we need to consider: cost, yields, and equilibria. We need to think about them every time. So yield, cost, rates. Consider these every single time when we're talking about industry. So now I want you to, again, numbers aren't going to be perfect here, but I want you to predict the sorts of pressure we might use, the sorts of temperature we might use. And again, I want you to make sure you're considering those three factors. On to the previous video and the questions there. So just very quickly, very quick answers here. So high temperature. This is an exothermic reaction, so we're going to shift to the left. A high pressure, we've got 1, 2, 3 moles on the left, 1, 2 moles on the right, so there we're going to shift to the right. This one, we are endothermic this time, so we're shifting to the right with a higher temperature. We've got 2 moles on both. Pressure is not going to change anything. Endothermic again, we're going to shift to the right. This time we've got 2 moles on the right, 1 mole on the left. Ignore the little numbers for this. So we're absolutely going to shift to the left with an increase in pressure. And last of all, we've got an exothermic reaction, so we shift left. We've got 2 moles of gas here. This is a solid, right? So this won't come into it. And we've got 3 moles of gas on the right. So 2 moles of gas on the left, 3 moles on the right. So we're going to shift to the left again. I hope that's helpful. Next time we'll start looking at KC and some of the calculations around equilibria. See you then. Until then, happy revising.